5. Process states. A process does not always run on the CPU. At any moment, a process sits in one of 3 states. This section explains those states, how the OS moves a process between them, and why those moves matter for keeping the CPU busy. The 3 states. A process in the running state executes instructions on the CPU right now. Only one process can run on a single CPU at a time. A process in the ready state can run, but the OS has not picked it yet. The process just waits for its turn. The OS decides which ready process runs next. A process in the blocked state cannot run at all. The process started some slow operation, like a disk read. The process must wait until that operation finishes. Only then can the process become ready again. Think about it. A blocked process cannot run even if the CPU is free. A ready process can run, but the OS has not chosen it. What makes these 2 waiting situations different? How processes move between states. The OS moves processes between these 3 states through 4 transitions. First, the OS can schedule a ready process. Scheduling moves a process from ready to running. The OS picks this process and gives it the CPU. Second, the OS can deschedule a running process. Descheduling moves a process from running back to ready. The OS stops this process to run a different one. Third, a running process can start an I/O request. That request blocks the process. The process moves from running to blocked. The process will stay blocked until the I/O completes. Fourth, when the I/O finishes, the hardware notifies the OS. The OS then moves the process from blocked to ready. The process can now compete for the CPU again. Think about it. Why does the OS send a blocked process to ready instead of straight to running? What would go wrong if a process jumped from blocked to running directly? The OS must make scheduling decisions. These examples show that the OS makes important choices. In example 2, the OS chose to run process 1, while process 0 was blocked. That choice kept the CPU busy and improved resource use. However, the OS also chose not to switch back to process 0 when its I/O finished at time 7. The OS let process 1 keep the CPU instead. That choice is not clearly good or bad. The OS scheduler makes all of these decisions. The scheduler is a policy that picks which process runs next. Different scheduling policies produce different results. Later chapters cover how these scheduling policies work. Section Summary. Every process sits in one of 3 states: running, ready, or blocked. The OS moves processes between these states by scheduling, descheduling, and handling I/O. The scheduler policy controls all of these decisions to keep the CPU productive.